like, I mean, it's a good speed, but it's not like record breaking. I was like, it's a good speed. I was never that fast, but we know my sporting abilities. They don't exist. I tried running. I tried to like it. Nope. Nope. But we've got Becca here who's running at 1 mile every 8 minutes in the direction of south 40 degrees east. And she goes that way for 20 minutes. And then she goes north 20 east for 16 minutes. So we're supposed to find her distance from her starting point. So we gotta figure out how far she is from home. So, might help to draw a picture, right? So, she's starting from somewhere, so I'm gonna make a start. We'll call this home. Boop, boop, home. And so she goes south 40 east. So she's gonna go from the house south 40 degrees to the east, right? Never eat soggy waffles. East, south and east. So she's going this way. And we know that this angle is 40 degrees. Wrong on my notes. So here is where she goes, I'm gonna change. I have a change of pace. So now she's gonna head north 20 east. So from this place, she gets her compass out. And she goes north east. So she's gonna go this way. This angle is 20 degrees for some amount of time distance. This guy is what we're trying to find. We're figuring out how far she has left to go to get home. So it might help to know, in fact, we really, really need to know how far she goes on each of these segments. So she goes 1 mile every 8 minutes, and she's going for 20 minutes. How many miles was that? 2 and some change. Not 2.4. 2.5. 20 minutes divided by 8 minutes. That's where we're getting that from. So this is 2.5 as a distance here, 2.5 miles. I'm gonna fix that too because it has a weird mark in the middle of it. 2.5 miles. And so on the purple segment, how far did she go? 2 miles. So I've got two distances. I have some information angle-wise. We gotta figure some stuff out. What's up? So, hang on. Give me more context on that one. So, if we knew that this was, hang on, that was supposed to be the eraser. If this was right there at the 90 degrees, we could do that, but we don't know that this is there. Maybe this is up here. Maybe I'm really bad at drawing pictures. Maybe that's way up there. So I'm going to move it up there just so that we don't have that temptation again. It doesn't, I'm not changing anything else. I'm not changing any angles. I'm just protecting us from that. Maybe it's right on the thing. It's not right on the thing. So I'm just going to make that a little bit clearer, not on the thing. What else do we notice?
Oh, there's a right triangle right there. From home.
Mm-hmm. As I say, it's not necessarily right. It looks right-ish, but it's not necessarily right. That's just called I'm bad at drawing pictures. As I say, we need at least one full angle, really, because we don't have all three sides. I need one angle. There is enough information here. We cannot assume this other side's 20, but we actually do have enough information to find this bit out. Why? Alternate interior. Yeah. Because our north-south axis, like that's always, north-south's always parallel. So since this is the same line, I know this angle is going to be the exact same as this angle. So this guy is also 40. So this whole angle down in this bottom piece, how much is this whole angle? 60. Now I have a side, an angle, and a side. So if I have side, angle, side, I can use one of my law of cosines to find our missing side. So I'm not even going to need to find out what these angles are. We'll be able to. We can if we want to, but we don't need to. Because I can use this top one from my law of cosines, the one that's set up with the A on one side, where we're taking and trying to find that distance. So it's going to be d squared. And our two other sides are these two distances that she ran, her 2.5 miles squared and her 2 miles squared. And then we minus the chaos piece. Minus our 2, I don't know if I'm have enough space to write it. Putting in values. 2.5 times our 2. And then I'm going to need to do a little moving real quick because I'm out of space and I still need to put the cosine in. Spoop. There we go. Cosine of our angle that we found was 60. So a lot of the pieces in here we can do, honestly, ourselves. Because what is 2.5 squared? 6.25. What is 2 squared? I ask such hard questions sometimes. 4. I forgot to change colors, but I asked the right question. Then we have 2 times 2.5 times 2. That gives us 10. Cosine of 60. I'm just changing colors. Yeah. Cosine of 60 is 1/2. That's a unit circle value. So then we have 6.25 plus 4 minus 10 times 1/2. So what are we getting for d squared? 5.25. So what is her distance? How far is she from home?
2.29 miles.
Entirely possible. My rounding might have been different. I had 2.219. But I might be wrong. Is it? I don't have a calculator. Somebody do it. What's our square root of 525?
2.291.
2.291. Then I will fix it because I put it as 219. Because sometimes I do. Sometimes I'm a little bit dysgraphic. A little bit. Just a little. So 2.29 miles. So we found her distance. Okay. Okay. So we don't need to find the other angles. All we needed was the distance. So be really careful on our pictures. When we draw things, don't let the fact that I accidentally drew this right on there at the beginning throw us off. It doesn't mean it's right on that thing. I'm just making up lines and drawing pictures to see our relationships. Okay? So let us practice it again. Tomorrow we'll finish up our law of cosine stuff. And that'll be it for the week.